In this video, we're going to continue exploring our new ways of commanding Falcon motors. And in specific, we're going to be talking about feed forward today. So what we're going to start off with, just like with PID, is some conceptual understandings. And then from there, we're going to talk about a very basic code integration of feed forward. So let's get started. So let's head over here. Let's talk about some conceptuals first. So here's just a quick overview of what we'll be talking about with this slideshow, and then of course we'll go into the code integration after this. So feed forward is another type of controller, so we can think of it like in something that's like a sidekick, if you will, to PID, that takes into account the physics of your mechanism. So, things like its inertia, its mass, its ability to move, the amount of torque it takes to actually move it, the friction, etc., all of it. It takes into account the physics of your mechanism to make a guess at how much effort you actually need to control it. So what it does is it figures out how much voltage you need to apply to a motor to control it smoothly and arrive at your different set points. Now the key thing to keep in mind is that we typically use feed forward or associate feed forward with things like positional control. And what we're going to be focusing on in this video specifically is controlling the different positions of an elevator. So imagine a linearly actuating elevator that goes up and down, and we want to code a specific position for the elevator to go to. So that's sort of the scenario that we're going to be trying to mimic in the context of feed forward today. So feed forward is basically modeled off of three variables. So we have case of S, case of V, and case of A. I'll call them KS, KV, and KA for simplicity's sake. Um, so KS is essentially the voltage that is needed to overcome the static friction within your motor. So just barely get the motor moving. kV is the amount of voltage needed to run the motor at a constant velocity. And I had this little part in parentheses here, while overcoming the internal countering electromotive force and any additional friction. Basically, how much voltage is needed to run the motor at a constant velocity. And Ka is the voltage needed to create an acceleration within the motor. So, get it moving faster than that constant velocity. So, like I hinted at earlier, rather, feed forward and PID are kind of used in tandem. And so, feed forward is essentially just a best guess at what your subsystem's physical constraints are. And it may or may not always reach your desired goal. So, something you could actually do is control everything with the feed forward. It's completely possible. But what we do is we use feed forward to get to our goal as close as possible and then apply a corrective PID loop to do any minute adjustments to reach our desired goal. Now, you might be wondering, well, okay, that part sort of makes sense. What about these three variables? Well, WPI provides a utility that's called sysid that makes it very easy to find KS, KV, and KA values by testing your mechanism with various applied voltages. So we're going to talk about that in a moment on how it works. So that is the general gist of feed forward. Remember, it's done. We usually talk about it in the context of positional control. And so now what we're going to do is do a very basic code integration of it. So we're going to head over to VS Code and we're going to make a new subsystem called elevator subsystem. So we'll do that right now. And all we need to do is create one motor. We're going to assume it has one motor. And the ID we're going to use, we'll do for now is number 9. So let's go ahead and do that real quick. Elevator motor ID 9. And remember, if you're connected to the Rio, you don't need to specify a canvas, as it assumes it's Rio by default. The next thing we need to do is set up our motor inside the constructor. Trigger the selected feedback sensor. Oop, not that. Integrated sensor. And that's all we're going to do for right now. So what I want to do now is introduce sysid. So it's part of the WPI Lib suite of tools. You can go ahead and search it real quick. I've got it open right here. And this might all look pretty complicated. So the one thing I will do for now is show you how to get it set up and how to use it on your robot. And if you need any help, you can always read the WPI Lib documentation on how to use sysid in case you ever get stuck in your setup, or how to interpret the data once it actually runs your subsystem. So what you're gonna do is, first of all, enter your IP address for your robot. And you might be wondering, well, what is that? Well, usually it's in the form of 10 dot, I'll write it down like this and I'll explain in a second. Dot two. So the team over here is usually your team numbers. So in this case, it's gonna be 10.19.23.2. And that's usually how it is. And if you have a one-digit team number, I believe it's just the one digit first. So that's cool to know. And then what you'll do is you'll set up your motor and your motor controllers. You can add multiple motors if you want to, but we don't need to. We only have one right now. And you can set up what CAN ID it's on, whether or not it's inverted, all of that fun stuff. In this case, we're assuming everything is at normal, and you can change the ID to 9. We know it's on the Rio. And if you, of course, if it's moved to a carnivore, you can change its name over here. And then what you do is you would deploy this, and it's going to try to, and it's going to deploy code onto your robot. And then what you're going to do is you'll enable the robot in autonomous, and then sysid is going to do a bunch of different tests to figure out what those KS, KV, and KA values. Again, I'm going to defer to the sysid documentation found on WPILib. It does a very good job of explaining how to interpret your data, how to set everything up correctly. So you can go ahead and read that if you are interested. So, assuming you've run sysid and you have everything good to go, um, again, remember, sysid is code independent, so you don't have to worry about what's written right now. You just need to make sure that this is set up correctly. What you'll do, or what we're going to do, is just show a basic implementation of feedforward. This isn't really the way we're going to be using things, but I figured that it would be good to sort of demonstrate I guess, sort of tie together the conceptual and code understanding of feedforward. So what we're going to do is we're going to use a WPLib object called simple motor feedforward, and we'll call it feedforward for now, equals new simple motor feedforward. No, I don't want that constructor. I want the one with 3 of them. And you'll notice it takes in KS, KV, and KA. So these are the values that you should be able to get from sysid. For now, I'm going to leave them all as 0. Then we're going to make a method. Now, remember that feedforward operates on a voltage basis, right? So what we're going to do is make a set method for the motor, but we're going to control its voltage. So set motor voltage, we'll call it. And we don't need to pick in any set points. I'll explain why in a second. Or actually, rather, sorry. We need to take in an argument for our set point, excuse me. So what we'll do is take in a double, and then we'll do elevator motor dot set control mode dot voltage, if that'll let me. Oh, sorry, dot set voltage, I believe that's what it's called. Yeah. Okay. So set voltage, and what we'll do is feedforward dot calculate, and what calculate will do is take in the velocity at which you want to move your mechanism, and in this case, that's going to be your set point, and it'll return the exact velocity, or sorry, voltage that it needs to run at. Now, in this case, for the elevator, it's kind of a little bit weird to set a velocity parameter. This simple motor feed forward is usually used for something like a shooter, so if you would like, you can try to integrate it here. But again, shooters can usually just run with PID, and you'll be fine. But what we're going to do now, or rather in the next video, is look at a much more elegant way of incorporating feed forward and PID, combining it all together to actually move this elevator with full motion profiling with a fancy Talon FX class called Motion Magic. So For now, don't worry about testing this just yet because we're going to have a much better way of controlling this elevator in just a second. I just wanted to show you how WPILib sort of integrates feed forward. So there you have it, and catch you in the next video.